to start with a warm-up. It's just to get your mind thinking. If you're on Zoom, you can see the warm-up by going to the home page. Going down to the guided notes. And going to the rational LCDs warm-ups. That's where you can find it on my classes, but I will. A lot of you have finished kind of working through some of these. I saw some good answers here. So let's kind of just step back. Oh, I think I have a question. Oh. Wait, did Grace say something? Oh. Oh, okay. All right, so the LCD, remember, is that term that we use like even before we even talked about algebra, right? When we added two fractions, for example, a half plus a third, the LCD is used to add them together so that the two fractions have the same denominator, right? So for example, we would say both of these fractions kind of can multiply together to get us 6. And we can add the fractions really easily, right? So this would be 5, 6. Okay. Oh, so now, unfortunately, LCDs aren't as easy as just multiplying everything in the denominator, because sometimes, for example, if I was multiplying 1/6 plus, I don't know, 2 times 4, 1/12. Okay. Yeah, the LCD isn't going to be 6 times 12, it's going to be 12, right? Because we're not just multiplying the denominators, okay? Okay, and I don't feel like adding the fractions together. The reason why we have 12 is because 6 is divisible by 2 and 3. 12 is divisible by 2, 2, and 4, no, 2, 2, and 3, right? Okay. So when we're multiplying things together to get the 12, we want to count for each item. This is actually a bad example because I don't want to give you something too difficult. Let's do, sorry, I didn't think of this on the spot yet. Let's do 6 and 14, how about that? Okay. If I wanted to find the LCD, you would look at the factors of 6, 2 and 3, 2 and 7, right? And instead of multiplying together 6 and 14, I would take the 2, the 3, but not count for the 2 again, right? I would take the 7, multiply these guys together, and 21 times 2, which is 42, would be my common denominator, okay? So essentially what the LCD is doing is we're multiplying everything in the denominator, but if we see something more than once, we're not going to overcount it, okay? So that might have been confusing, might have not been. Let's go to this example here. Okay, we have this equation. We have a bunch of things in the denominator. What did you guys think the LCD was? Mm-hmm. 3x plus 2? Mm-hmm. Anything else in the LCD? Good start. What else goes in there? X plus 4, good, right? That's in the denominator. What else? Yeah, x minus 2 should go in there too, because that's not, we didn't write that down yet. Anything else? 5, right? The 5 goes in here too, okay? Now, are we going, we see 2 3s. Am I going to write 3 twice? No, right? Because I'm already accounted for it, okay? One thing I've seen by walking around is some of you have written the LCD by putting commas between these guys. I don't want to see commas because these guys are being multiplied together, okay? So let's not put commas between these guys. We're just multiplying them. And I can even sort of simplify this by multiplying the 5 and 3 to get 15, right? X plus 4, x minus 2. Okay, so this is my LCD. Any questions so far? Okay, perfect. Now we have an equation. Remember, we did this sort of rational equation solving and we got to a point where we had a solution. We plugged the solution in and it didn't work because we were dividing by 0. We want to make sure we find all the x values where if we plug them in, we'd be dividing by 0. Okay. Does anyone remember the process to find those x values? Yeah, set each of the things in the LCD to 0, right? So I can take my 15 and set it to 0, right? I can set x plus 2 and set it equal to 0. X plus 4. And x minus 2. If you can do this in your head, go ahead and do that. But 15 equals 0, that doesn't have a solution, so we can just ignore that. Subtracting 2 on both sides gives us x equals -2. I'm not going to solve each one, but we have x equals -4 and x equals 2. Okay. So if we solve each of these equations, we're getting 3 x values that if I plug them into my equation, I would be dividing by 0, which we can't do. So that means these aren't solutions to our equation. Okay. Any questions on number 1? Perfect. Okay. Let's go to number 2. We have this equation, a lot of crazy things going on. Can someone tell me what they think the LCD is here? Yes. Uh-huh. There's one more thing or 2 more things. Yeah. Okay. So basically, I think what Yaz does is she just looked at the denominator. I'm going to multiply everything in here, but I have this 2 here. That's repeated. I already wrote that down, so I'm not going to write it again. And I also have the x minus 2, which I already wrote down, so I'm not going to write that factor either. Okay. So my LCD is just going to be this. You can multiply the 5 and 2 and get 10 x plus 4, x minus 2, x plus 2. So that would be my LCD. Either one would work for me. Any questions so far? Good. Okay, what values can't be solutions? You can set each of these terms equal to 0. Anyone can kind of just tell me in their head what values weren't solutions here? -4. 2 and -2, right? If you want to go through that systematic way of setting each of these guys to 0, solving for x, I encourage you to do that, but if you can do it in your head pretty easily, go ahead and do that too. Okay. Any questions on this warm-up? Okay. I think we're good with kind of basic LCDs. We're going to go back to our set of notes from last time, and we're going to start off on example number 7. Does anyone need the guided notes from last time? There we go. Anyone else? Good. Here we go. So example 7 is very similar to your warm-up. It looks like we're just trying to find the LCD. Any guesses on what the LCD might be? Based on our last sort of process? Yes? Yeah, okay. I like how you're saying that. Let's see. So if it were me saying this based on the previous information, and this is wrong, so don't write this down, I would say, okay, the LCD is easy. Just 3x plus 9 and x plus 3 is like not repeated, so I'm just going to write that down. Yes, what made you think to kind of, what made you think that it was 3 times x plus 3?
Because if you divide 3x plus 9 by 3, you get x plus 3, so they're somewhat equivalent.
Yeah, so yeah, it says, okay, if I take 3x plus 9 and divide off by 3, I'm left with x plus 3, right? Okay, so essentially what you're saying is that 3x plus 9 is 3 times x plus 3, right? You can factor out a 3 from the denominator, okay? So instead of writing the question like this, maybe I can write the denominator, maybe I can factor the denominator and get something a little bit easier to work with, okay? So now that I know the denominator isn't just 3x plus 9, it's 3 times x plus 3. If I want to find my LCD, I know there's a 3, so I'm going to write the 3. There's an x plus 3, so I'll write x plus 3. But I don't need to write this x plus 3 because I've already accounted for it when I wrote x plus 3 before. Okay. So LCD can get a little bit even more complicated when we can factor out the denominator. Okay. So when you're looking for the LCD, first you're going to ask yourself, is there anything in the denominator I can simplify or factor? Then you're going to take everything in the denominator and make sure you're not double counting for things. Okay. Any questions so far? All right. What value can't be a solution here? Well, you got -3, which is good. Let me go through this more systematically. 3 equals 0. X plus 3 equals 0. Okay. Solving the left equation isn't going to work, right? But if I subtracted 3 on both sides, x equals -3 is not going to be a solution.
So would we not include 3 equals 0 for the cannot be solutions, or does it not really matter because either way it's not a solution?
Yeah, like that 3. Okay, I'm setting each of the parts equal to 0. 3 equals 0. How many solutions does that have? No solutions, right? So no solutions. It doesn't really matter, right? Because I don't have to write, oh, there was no solutions there, right? We're just looking for values of x. Good question. Any other questions here? Okay. Here's where we're going to get to the somewhat hard part. We're going to try to put everything together, and I know this is going to take a little bit of time, but when we want to solve an equation with rational expressions, first we'll determine the LCD, which I know kind of determines if the question kind of goes on or not, but we'll talk about that. Secondly, you're going to find everything that makes the LCD equal to 0, so find the values that can't be solutions. Third, you're going to take your equation and multiply everything by the LCD. So everything in your equation is going to be multiplied by whatever you found. You're going to solve the equation, and then at the end, you're going to make sure that your solutions can be solutions. So you're going to compare your answer to the values that can't be solutions. And I think an example might make that more clear. Okay, let's do an actual example here. Okay, we have this example. We have a lot of stuff in the denominator. We want to find the LCD, and remember, when I'm looking for the LCD, the first thing you want to ask yourself is there anything I can factor or simplify in the denominator? Is there anything here? Yeah, yeah, 2x minus 4. I can take out a 2, right? They both share a 2. So this is actually 2 times, well, what's in the parentheses here? X minus 2, good. Okay, so 2x minus 4 is the same thing as 2 times x minus 2. Okay, any guesses on what the LCD is? Stephen? Good. We're not double counting the x minus 2, so I'm not going to write that again. Okay, LCD looks pretty good. What values of x make the LCD equal to 0? 2 and -3, perfect. If you want to go through that more systematically, go ahead. Okay, here's where we haven't really gotten to yet, okay? The trick to solving these types of equations is we're going to take our equation and we're going to multiply it by the entire LCD, okay? So to make this a little bit more clear, I'm going to write the equation again. 3 over 2x minus 4. Oh, and instead of writing the full version, 2x minus 4, I'm going to write the factored version, 2x minus 2. Okay, they mean the same thing. Minus 5 over x plus 3 equals 2 over x minus 2. Okay. So I just rewrote the equation. I want to multiply the LCD by the equation, which means I have to do it on both sides, right? So I'm going to take my LCD, 2x minus 2, x plus 3, multiply it on the right side, which means I also have to multiply it on the left side. 2, x minus 2, x plus 3. Okay. Now we're here. If you feel pretty comfortable with doing, skipping a couple steps in your head, go ahead and do that. But I feel like a lot of people kind of get a little tripped up when they get to simplifying this. Okay, so I'm going to take this step by step. You can do the steps if you want, but if you feel more comfortable skipping them, go ahead. But what I'm going to do is this entire thing is being multiplied by two things being subtracted, which means we can kind of distribute that multiplication to each term, right? So what I'm going to do here is I have 2x minus 2x plus 3, which is essentially all of that over 1, okay? And I'm going to multiply the numerators and the denominators for both of these terms. And this might make more sense when I actually do it, okay? So when I'm multiplying by the first term, I'm going to get 2x minus 2, x plus 3 times 3, all over 2 times x minus 2. Okay, so that's just multiplying by the first term. I'm subtracting off a 2x minus 2, x plus 3 times 5 over x plus 3. So all I did was I took that LCD, multiplied it to both of the terms being subtracted. Okay. Now on the right-hand side, there's no subtraction or addition. So I'm going to take the LCD and just multiply it by the term on the right. 2 times 2 times x minus 2 times x plus 3 over x minus 2. And I know it's a lot of writing, but I promise you, you'll make less mistakes if you do this step. Okay. Now what we can do is we can look at what we just wrote here. Does anyone see anything we could do to simplify this, Stephen?
You can cancel the denominator.
Yeah, right. So on the left-hand side, we have a 2 on top and a 2 on bottom. We've got a x minus 2 on top and an x minus 2 on the bottom. Okay. Same thing with the middle term. There is an x plus 3 on the top and bottom. And on the right-hand side, we have an x minus 2 being canceled out. Okay. Once we're done doing this, we can write what's left. Okay. Now, personally, I like writing any number to the left-hand side of any expression. So for example, even though this 3 is on the right, I kind of like moving it to the left just so it's easier for me to visualize at least. Okay, so this is going to become 3 times x plus 3, okay, minus, well, we have a 5 and a 2, so I'm just going to multiply that to make 10. 10 times x minus 2 equals, okay, and we've got 2 times 2, which is 4, times x plus 3. Okay. Is everyone with me so far? Okay. Any ideas on what we can do next? Stephen? Yeah, we have multiplication by a bunch of added terms. I can definitely distribute everything here. Okay. So I'm just going to do that. 3 times x is 3x. 3 times 3 is plus 9. Okay. Be careful on this negative 10. Okay. When I'm distributing this 10, I also want to distribute the negative sign. Okay. So negative 10 times x is negative 10x. I also have to multiply the negative 10 by the negative 2 to get positive 20. Okay, so don't forget that negative sign. Okay, we got 4 times x, which is 4x, and 4 times 3, which is 12. Okay. Now we're getting somewhere that we can, that we think is pretty familiar, right? Looks like we have some like terms here. We've got a 3x and a 10x, so we can subtract them to get negative 7x. We've got a 9 and a 20, and that gives us 29. And let's see, we've got a 4x plus 12. Well, we can't do anything with that. Darn it, looks like I'm running out of space. That's okay. Okay. So what's my next step here? Did you say add 7x? Is that what you, minus 4x? Okay, we can do that. Let's subtract 4x on both sides. Minus 4x, minus 4x. So negative 7 plus negative 4. I'm bad at mental math. 7, 8, 9, 10, 11. Perfect. Okay, so we got negative 11x plus 29 equals 12. And I guess we have to subtract the 29, right? Minus 29, making me do mental gymnastics early in the morning. Negative 12, 12 minus 29 is bad at this. I'm gonna cheat. 17, did you say so? 17, perfect. Negative 17, right? Okay. All right, and I guess all we have to do is divide by negative 11, and x equals positive 17 over 11. Okay. I'm sorry that step 3 and 4 kind of took too much space. I'm actually going to move step 5 down here. Okay. Any questions on how I got x by itself? Okay. Let's talk about step number 5. Okay. I want to know which values of x that I calculated, okay, are solutions to this equation. Okay. Essentially, what this question is asking me to do is I'm going to take my answer from part 4. Okay. I'm going to compare it to the values that can't be solutions. Okay. So, for example, if I did all of my work and I got x equals 2, that can't be a solution because in step 2 I said it can't be a solution. Okay. Now, luckily for us, we got something that doesn't match the things in step number 2. Okay, so this means that 17 over 11 is a good solution. It's not something that can't be a solution. So 17 over 11, because it isn't 2 or negative 3. Any questions on what I've done here? Okay. I will say, I think this is the question that everyone got scared of on the final exam last year. So I think this is the hardest part of, or one of the hardest things that we do in the class, because there's a lot of different steps and a lot of places where you can mess up. Okay. If we feel kind of comfortable, I'm going to give you about 5 minutes to work on example 9. I'm going to say, let's not go over this as a class until Monday, because I want to give you time for your quiz, but let's take 5 minutes, work on this, and then we can talk about it next class.